The Mystery of the Lunar Ionosphere, presented by Science at NASA. How can a world with no air have an ionosphere? Somehow, the Moon has done it. Lunar researchers have been struggling with this mystery for years, and they may have finally found a solution. But first, what is an ionosphere? Every terrestrial planet with an atmosphere has one. High above the planet's rocky surface, where the atmosphere meets the vacuum of space, ultraviolet rays from the sun break apart atoms of air. This creates a layer of ionized gas, an ionosphere. Here on Earth, the ionosphere has a big impact on communications and navigation. For instance, it reflects radio waves, allowing shortwave radio operators to bounce transmissions over the horizon for long-range communication. The ionosphere also bends and scatters signals from GPS satellites, sometimes causing your GPS tracker to misread your position. The first convincing evidence for an ionosphere around the Moon came in the 1970s from the Soviet probes Lunar 19 and 22. Circling the Moon at close range, the orbiters sensed a layer of charged gas tens of kilometers above the lunar surface, containing as many as 1,000 electrons per cubic centimeter, 1,000 times more than any theory could explain. The idea of an airless Moon having an ionosphere didn't make much sense, but the evidence seemed compelling. In fact, the Moon isn't quite as airless as most people think. Small amounts of gas created by radioactive decay seep out of the lunar interior. Meteoroids and the solar wind also blast atoms off the Moon's surface. The resulting shroud of gas is so thin, however, that many researchers refuse to call it an atmosphere, preferring instead the term exosphere. The density of the lunar exosphere is about 100 million billion times less than that of air on Earth. Not nearly enough to support the kind of ionosphere the lunar probes saw. For 40 years, the Moon's ionosphere remained a mystery until Tim Stubbs of the Goddard Space Flight Center published a solution in 2011. The answer, he proposes, is moon dust. Stubbs, a 30-something scientist who wasn't even born when the Moon's ionosphere was discovered, read the accounts of Apollo 15 astronauts who reported seeing a strange glow over the Moon's horizon. Many researchers believe the astronauts were seeing dust. The Moon is an extremely dusty place, naturally surrounded by a swarm of particles. Think Pigpen in the Charlie Brown comics. When these floating dust grains catch the light of the rising or setting sun, they create a glow along the horizon. Stubbs and colleagues realized that dust could be the key. UV rays from the sun hit the floating grains and ionize them. According to their calculations, this process can produce enough charge, that is, positively charged grains surrounded by negatively charged electrons, to create the Moon's ionosphere. An ionosphere made of dust instead of gas is new to planetary science. No one knows how it will behave at different times of night and day, or how it might affect communications and navigation on the Moon. With NASA's Artemis probes orbiting the Moon now, and the Laddie spacecraft scheduled to launch in 2013 to study the Moon's exosphere, more information should be available soon. Updates will be posted at science.nasa.gov.